Okay. Hi, everybody, and welcome to the NCDS DataBytes Lunchtime Webinar Series. Today's speaker is Jeff de la Beaujardiere, and he is the Data Management Architect for the National Oceanic and Atmospheric Administration and Chair of NOAA's Environmental Data Management Committee. Jeff also serves on the interagency and international groups aimed at enhancing data sharing and interoperability, including the International Group on Earth Observations Data Management Principles Task Force, the U.S. Group on Earth Observations Data Management Working Group, and the Open Geospatial Consortium. In those roles, he works toward the vision that NOAA's rich and unique data holdings shall be discoverable, well-documented, compatible, and preserved for future use. So today's talk, which is called the NOAA Big Data Project, will last about 30 or 40 minutes. We'll have time for Q&A at the end. And the way we run it, we want you to type your questions into the chat box, and we'll hold them till the end of the talk, read them back to Jeff, and he will answer your questions. So without any further ado, welcome Jeff, and welcome everybody.
Great. Thank you very much for that introduction. Let me resume screen sharing here. Great. You should be able to see the opening slide of the presentation, I assume?
We do.
Great. All right. So I'm going to tell you about NOAA's Big Data Project, where we're trying to leverage the value of our rich data holdings with industry and others. It doesn't have to be industry, but that's definitely part of it. NOAA is part of the Department of Commerce, so this is of interest to that department as a whole. In fact, this project had initially been announced by the Secretary of Commerce. So my name is Jeff de la Beaujardiere. I go by Jeff DLB for short. I do want to give credit for some of these slides to Dr. Ed Kearns, who is serving as the technical lead of this project. He's at the National Center for Environmental Information in Asheville, North Carolina. And also, hold on, it's not clicking. There we go. All right. Also, just want to flash up this list of other people involved. There's quite a few people from NOAA, some of whom are actually not with us anymore, but were instrumental in getting this really going. And then people at one of our cooperative institutes at NC State, and then various people at the companies, the cloud companies that we're working with, who have been collaborating extensively, especially on the NextRad data, which I'll talk about during this talk. So we're seeing an increasing user demand for our data. This chart here shows, as a function of year, the amount and type of data we delivered. We've delivered, in fact, it keeps going even higher right now. This ends at fiscal year 14, but it's in the several petabytes per year that we've sent out. Currently 8 petabytes per year, according to that first document, serving lots of people, many web hits. And one of the problems is this imposes a significant load on the NOAA infrastructure. We have to store the data, and then we have to send it out, and we're often sending out multiple copies to separate users, so that's a bit of a problem. So the premise of this partnership is, we have these large and diverse data holdings. It's very expensive to acquire them, and the acquisition is done at taxpayer expense, as is the storage of them and the dissemination. And we feel that lots of these data are not as well utilized as they could be. Experts know how to get them, know what to do. We have designated customers that have things set up to use the data, but other people can't always get to the data easily, or once they get it, it's just maybe hard to use. So we feel that there's some untapped economic value in those data. We've already seen that a lot of our weather observations have essentially sparked the creation of a private weather industry. And another analogy is the GPS data. That's not NOAA's, but when the government made that signal more precise, or the precise version of it available, it spawned a whole new industry. So there's this question of, is there latent value within our data that could be extracted if there were better access to it? So this project is all about trying to improve that access and usability by putting data on the cloud where anybody can work on that easily. Click, there we go. Okay, so just kind of conceptually at an architectural level, what we're trying to do is the following. At the bottom, you see the master copy of our data, which would include Earth observations, but also model outputs like weather models and so forth. And we are providing and will continue to provide various services to get to these data. We have a catalog, the NOAA Data Catalog at data.noaa.gov. We have online access services of various types. Unfortunately, they're not all standardized, but there are, in theory, ways to get all or much of our data. We have good metadata. We have a variety of formats, not all standard, but we're working on that. So these are things that we're doing and we're going to continue to do. But then in this project, we're talking about sending a copy of our data out to the cloud. It's not the master copy, it's just a working copy, kind of a one-way push to cloud infrastructure providers, so that people can work with the data, can develop or use tools for data integration, data analysis, and work on customized products, applications, new decision support tools, whatever, for new customers that we don't have yet, maybe even whole new lines of business that we have not envisioned yet. So architecturally, it's kind of what we're trying to do. It's taken a little while to get here. The official announcement was in April 2015 by the Secretary of Commerce. You can see a little screen grab here from their website. This was strange in a couple of ways, because one of the issues, or one of the fundamental concepts, is that this is a no net cost thing. We're not actually funding private companies to put our data on the cloud. We're asking them to take data that they want for free and then recoup their costs in other ways, for example, by charging people to do computation on the data as they make value-added products and services, and then possibly downstream even those people could recoup those computing costs by charging for custom products that are different than NOAA's raw data. We had issued an RFI back in February 2014 and had a very enthusiastic response. About 200 companies were involved in responses, sometimes jointly. We got about 70 responses. Many of them were very good. We held an industry day in October 2014. Again, got about a couple of hundred companies participating there. But it did become clear that the concept was a little bit new, and companies wanted to tread cautiously, wanted to participate, but were wary of committing too many resources without knowing if there really was going to be a business case here. So we decided to treat this as an R&D project rather than a traditional acquisition. So in the end, we signed 5 CRADAs, Cooperative Research and Development Agreements, in April 2015. And that's how we're operating now, under this R&D agreement. We hit the 5 are with Amazon, Google, IBM, Microsoft, and Open Commons Consortium, formerly known as Open Cloud Consortium. And these are all infrastructure as a service companies. Well, in the case of OCC, more of an academic group that are the anchors of the project. And we envision partners would work with them who want to use their cloud and do things with the data. So anybody can join these alliances, one or more of these alliances. In fact, in this next slide, this illustrates each one can have multiple partners. Some of the partners might be the same, who are working with several groups. Others can be individual, and each of these has at least one partner who's working with them. What we're seeing is that the cloud providers are experts in cloud infrastructure. They're not necessarily experts in earth science data or in some of the things you can do with the data. So it's very important to have these external partners. But we, at the same time, don't want to enter into individual agreements with all possible partners. So we're trying to mediate through these 5 R&D agreements, to the downstream partners, where they handle some of that negotiation, discussion, whatever. And then, as I said, we're still keeping our own copy of the data and our existing services. We're not turning anything off as part of this project. This is an additional method of data distribution and access. So we established a couple of rules in the CRADA. One was we wanted to really have a level playing field. So Any of these partners who want the NOAA data, any of the cloud collaborators who want NOAA data, you can get it on equal terms. There's no privileged access to for any one cloud provider. They don't have to take all of our data, but they have the same opportunity if they want it. The data we send them are supposed to remain free and open. They could charge a cost recovery piece. They're not required to, but they could. And they can charge for new value-added products, but the raw data is supposed to remain free. So these CRADAs are 3-year agreements with 2 additional 1-year options, and we'll see as we go what it leads to, whether we would continue the CRADAs, whether we formalize something a little bit more with service level agreements to the cloud providers and so forth. Any one of us could, in theory, walk away. I don't think that's going to happen right now. Things are going pretty well. And the CRADA does stipulate that NOAA is not funding the collaborators. However, the collaborators can actually provide funding to us if needed, for example, for an infrastructure improvement. Let's say somebody wants data faster than we can give them from some source. They could fund the installation of new network capacity, for example. Or if we need to move some kind of gateway machine inside of our infrastructure, they could do that and work with us to make it happen at their expense because they felt it would be worth doing. So how is this going to work? We're letting the collaborators and their downstream partners choose what data sets they want. Some of the early discussions of this talk about all NOAA data. We're not going to send all NOAA data. I mean, we could, it's not ruled out, but I don't think we will. That not all of it is of equal interest to everybody, and it is a significant effort sometimes to get individual data sets across. So we're letting them choose what they want based on their understanding of what they think they can do, what business case they might be able to come up with. And together with them, we figure out how do we get the data to them? What's going to be the most effective way? It has not been easy with our first major data set, as I'll mention in a minute, but it's always doable. It just takes a little time sometimes to figure out the best way. So we've been engaging a lot of subject matter experts inside the agency and then with the collaborators to just discuss the technical requirements and methods for all of this. And then ideally, these collaborators will create applications in the new value-added products and services of this. And then again, to stress, we are continuing services we already have. We're not turning stuff off. So what are some of the initial data that was requested? With the RFI, request for information, asked people, if we were going to do this, what kind of data would you want? These 4 types of data were very commonly requested. NexRad in the lower right, which I'll talk about some more, is the radar data. You see some of these at airports and so forth, measuring precipitation. Then MRMS, multi-radar, multi-sensor, is a product derived from the radar data, kind of easier to use, regridded, certain events kind of found in there and cataloged. GOES and GOES-R, geostationary satellite data, are of big interest. And then numerical models. This is actually of greatest interest because what's happening is we compute weather models and we don't make available every time step in the model. We just can't. So we do a computation at a fairly fine time resolution and then send out, say, 1/10 of the output. And there's interest in getting all those intermediate time steps if we can make that happen. This is actually, I think, going to be the toughest problem to make that happen because it requires access directly from our supercomputers. So the first one we chose was NexRad. NexRad level 2 weather radar data. These data were already publicly accessible. They were stored in our archive, but it was very difficult to get to the data. First of all, the size, since I think 1991, is huge, 270 terabytes compressed. The format is kind of specialized, and they were on robotic tape. So if you want to get the data, you place your request, and then a few hours, maybe a couple of days later, it would tell you, okay, your data has been staged on this FTP site coming down. So if you want everything, it's very difficult. In fact, one of our original collaborators, Alan Sternberg, who was here on a Presidential Innovation Fellowship, was one of the founders of the Weather Underground. Maybe you've heard of that website. And he had once tried to get all of the NextRad data, and it was taking him more than 1 day to get 1 day's worth of data. So he realized, he probably would never catch up and that it was not worth doing. But now as a result of this project, he could get that. So we also chose NextRad because it's a highly popular data set for use in industry. There are already people using it, people understand it fairly well, and there's a variety of things you can assess, phenomena you can analyze by looking at these data, weather-related phenomena, and as we've learned, other things, for example, bird migrations. Apparently you see the signals of birds as they fly by in front of the radar, and in the right conditions you can actually get a lot of information about bird flocks and bird migration. There's a project actually working on that right now. So until this project, utilization of the entire NextRad archive had never been realized, but now you can do that. We also chose NextRad because we had done some recent work on reprocessing the data. And so half of the data was already on spinning disk as opposed to on robotic magnetic tape. It was with CICS, the Cooperative Institute for Climate and Satellites. And so we were able to send the first half of the data very quickly up to the first provider, which was Amazon. First half took a few days, a couple of weeks. The second half took a few months to actually read off tape and stage and send to them. So it took a while to get all of it there. But the initial start was good, was easy. And then finally, NextRad is also highly ranked in something called the National Plan for Civil Earth Observations. This was put out by the White House, by the National Science and Technology Council, which looked at observing systems from various agencies and their relative impact to other agencies and their missions. And NextRad, I don't know if you can read the text here, but it's number 2. Next Generation Weather Radar was number 2 on that list. GPS was number 1. Landsat is number 3. In fact, Landsat is available on Amazon as well. And then geostationary satellites, GOES, are number 4. And I'll talk about GOES also in a minute. So the data were archived at NCEI, National Centers for Environmental Information. That's the new name for what used to be the National Climatic Data Center, National Oceanographic Data Center, and National Geophysical Data Center, now united in one program, one name. Worked out to about 270 terabytes compressed. If you uncompress it, it's a petabyte, so it's quite a sizable data set. And we move the data from the tape to the disks at CICS NC and then send it out. That was very helpful because CICS NC could serve as a middleman, and that minimized impact on our operations. But it also revealed that we actually didn't have a good place to stage data. So this is one issue we're going to have to work with for future data sets. We don't just have some big empty pool of disks sitting there that is publicly accessible, that we can put data on and then have people grab it from. So we're talking about how we do that. And then as we make updates, this disk would just get updated as we receive new data in the archive and process to put it there. So that got all the archive data, but there was also great interest, obviously, in the current data, the real-time data. So the Weather Service is the part of NOAA that operates these radars, and they were already pushing data out through the IDD-LDM, that's Unidata's Internet Data Distribution / Local Data Manager system, which a number of universities and others are involved in. They were already pushing data out that way, and so we were able to plug that into our cloud providers who wanted the real-time data, and now they're getting the current data. So now these data have been moved to 4 of the collaborators. One, IBM, decided not to take it. They don't want to work on it. But Amazon, Microsoft, Google, and OCC have all grabbed the data. Amazon was the first and is kind of the farthest ahead on this. You can actually get to it now at the URL shown on my screen. There's a NextRad on AWS page. They have a similar project, by the way, which is Landsat on AWS, so both of those major data sets are available on Amazon. And they have everything from 1991 to 5 minutes ago, current stuff. Gives you a single point of access on S3, that's the Amazon Simple Storage Service. Amazon has waived the egress charges. Normally to get data out of S3, you would pay. It's a small amount, but you'd still pay, and would add up to a lot if you wanted to get the whole archive. So that's free, but we are encouraging people not to download it to their own disk, their own infrastructure, but rather to compute in place, because that's part of the goal of this project, is to let people just compute where the data are, move the computing to the data instead of moving the data to the computing. That being said, if you do want to compute on the data, there is a charge. You have to pay Amazon, but that's not very high. That could be from pennies an hour to $5 an hour, depending on how much of a hurry you are and whether you want the most powerful machine or a small machine. But there's all sorts of ways to compute on the data. Amazon made a public announcement about this last October. Google, Microsoft, and OCC have not yet made public announcements about this. I'm actually not sure whether they will or whether they're just kind of working on internal projects directly with collaborators, and then those collaborators would announce the availability of new products and services based on the data. But in any case, right now, anybody can go to AWS and compute on those data. We, NOAA, are also steering people to these new services. So if you go now to the NCEI page about radar data, you will find links to how to get the data on Amazon. And if the other ones make a public entry point, sorry, I'm getting a lot of background noise right there. An unmuted phone or something. As other companies make their links publicly available, we'll also add these to our webpage. And one thing of interest, kind of an unexpected benefit, I guess we should have expected it, but it was nice anyway, is that we're seeing a 60% decrease in volumes of archival data orders since this has happened. So people are now, who do want the data, are going to Amazon to get it or to use it and not getting it out of our archive, which is great for us because it's easy to use and we're not having to read it off tape and so forth. So that's a good statistic. And we're also trying to integrate the data into what's called the NOAA Weather and Climate Toolkit. This is a screenshot of that, which does some visualization of the data and knows how to read the files. So you can see one of the tabs now here is the NOAA Big Data tab, and it's letting you get data directly from Amazon or work on data directly at Amazon instead of getting it from us. So it's a nice enhancement there. Doing this project actually led us to make improvements to our own data. First of all, we checked that we had everything, and we found files that were corrupted. We found about 20,000 corrupted files. Now that sounds like a lot, but there were 180 million files, so it's only 0.01%. But those were identified and those were fixed, and then the fixes were put back in the archive. So now our archive is better than it was before as a result. And we do want to thank the Climate Corporation for having discovered the issue so that we could fix it. And then, of course, we told the other collaborators, hey, we've made some fixes, go and get that. So what's the role of NOAA here? If we kind of create this market ecosystem where NOAA provides data and other people are doing stuff with it, are we still relevant? And I think we are, because there are a number of things we need to do. First, we need to ensure that all of the data still remain openly and freely available. That's always been our goal for these types of data. It's also required by things like the U.S. Open Data Policy and written NOAA policies. So all data do need to remain freely available, whether or not one of the cloud providers wants it. But maybe more importantly, we understand the data. I mean, we built the observing systems, we operate them, we have the scientists, we know the algorithms, and so we have the objective scientific expertise on how to use these data and suitability for various types of purposes and so forth. And then also, we want to ensure the data are preserved for the long term in our archive and have sound data management applied to them. So no matter how much this project takes off, NOAA's role is still going to continue. So far, what's been the benefit? Well, we've got this very large and unwieldy data set that's been liberated for use by industry and the public at no cost to the taxpayer beyond the original cost of observations, of course. Data access is seamless. You can find the historical and the real-time data same place, same way. And that's important because a lot of the current uses of NextRad focus on the real-time observations, but the historical data does provide a lot of context. If you want to do things that are longer-term studies, for example, if you wanted to look at, if you're from the insurance industry and you want to talk about the frequency of tornadoes or something like that, it's really good to have the historical data. So we feel that new business opportunities are being created. Our collaborators are working with their partners on things like custom severe weather products, bird migration studies that I mentioned, and these are now easier to develop than they were. The applications can be developed faster because the data are adjacent to the processing. It should be much quicker to develop an application, get it to market if you want. It also lets you experiment, right? You don't have to establish a big infrastructure to get a whole bunch of data before determining whether you can make a useful product out of it, because it's right there. You could just set something up, do a little computing, see if it works, tweak it, and keep going. I had mentioned that we had done a recent reprocessing of the data. That took years. Now, if we were to run that reprocessing on Amazon, it would take weeks. So that's just a kind of a benchmark of the time savings of having the data sitting in the cloud ready to be computed on. So what's next? Several other data sets have been requested. Looks like GOES is going to be up next. That's the geostationary satellite data. Weather forecast models, definitely got to work on that. One of the collaborators has been very interested in fisheries data. So that NOAA includes the National Marine Fisheries Service. They don't have very large data sets necessarily, but they have many, many thousands of very small data sets about fisheries catch information. And one of the partners is interested in that. And then other NOAA data to be determined. So on GOES, what's the current situation? GOES stands for Geostationary Operational Environmental Satellites. It's actually a constellation of several satellites up there with a new one to be launched soon. The newest one is called GOES-R. It's not up there yet. And it's been ranked the 4th most impactful observing system in that US Geo White House study that I showed earlier in the talk. But again, just like NextRad, it's not easy to get to. As Ken Knapp has pointed out, you have to find out what satellites were operating, you have to get the data, get them on your disk, handle duplicates because they appear, learn how to read this GVAR format, calibrate the data, remap, subsample, process the data. I mean, it's difficult. It requires a lot of infrastructure and knowledge to do that. So we're hoping that putting it on the cloud will simplify at least some of those things. What we're planning to do is really provide an improved data set. First, in terms of accessibility, get the data out of class, which is the tape archive system. And then as we send it to the collaborators, remap the data and reformat it from the GVAR format, which is kind of a specific format to that satellite, to HDF5, much more well-known format. And at the same time, get rid of duplicates and apply some calibration. So then these Big Data Project collaborators will be able to provide the seamless access along with the computing in a single API or access point, at least one API per cloud to the entire time series. And then hopefully we'll have external partners who are developing value-added products on this. So in conclusion, we've worked with these 5 cloud infrastructure as a service providers on an R&D basis to host NOAA data. Moving to NextRad data first because it was easily done and there was a market need for it. Amazon does seem to have had some good experience so far. People are using it. They can measure uses of the Amazon infrastructure on this, and it's reduced the load on the NOAA systems. Next, we're working on the GOES data. So that should be, I'm not sure when that'll happen, but hopefully in the next few months. We actually just put together or made available a test data set for the collaborators who want it so that they could kind of prepare for the new GOES-R satellite when it comes, which is going to have very high volumes, and things will be a little different there. I think the success of this project requires not just the access to the data, but the expertise that NOAA can provide on the algorithms and so forth, and also some viable use cases or business cases for the data. And then finally, I would encourage potential developers and users such as yourselves to engage with any of these BDP collaborators at this website. In fact, I'll just click. It's a pretty simple web page, but should open up here. And we're going to revamp it, but whatever. From here, you can get a little bit of information about what each collaborator is doing and figure out how to contact them. So if you want to work with one of them or more than one of them on either NextRad or GOES or some other data set you'd be able to do that. So I'm going to end there, and I'll be glad to take any questions if you have any.
Okay, Jeff, thank you so much. We do have some questions here, so I'm going to start reading them back. And first question is, do you know of other federal agencies with data that have plans to do something similar?
Not officially yet that I know of, although several agencies have seen what we've done and are interested in somehow collaborating or doing the same thing. So, you know, we're trying to figure out, how do we do that? I mean, the deal with the NOAA CRADAs was it's NOAA data, and you know, that maybe provides some constraints on volume and so forth. So it's a little bit up to these 5 collaborators whether they want to, you know, accept data from other agencies to include in this, how they want to do that. Do they want to sign new R&D agreements? Certainly other agencies have data that would be useful, even if they're not high volume. You can imagine that, you know, things like road data and, you know, population locations and things like that would be very nice to have if you want to study, say, the impact of weather on infrastructure and population. So no formal projects by other agencies I know of, but there's certainly some interest.
Okay, next question then is, do you have additional use cases you can describe briefly? And if you need clarification on that, see if we can get that any.
Yeah, no, I don't think I need a clarification. Let me think of the ones I've heard of. I think one is the sort of insurance use case, or maybe the reinsurance industry, which is the industry that insures interested in historical weather patterns. I have heard about the fisheries use case, but I don't feel comfortable describing it right now because they seem to still be in discussion with that. And honestly, I'm not sure what the other use cases are. I mean, with NextRad, it's weather events, so you know, you can imagine better knowledge of severe weather historically and in present is important. Well, I guess you could say a few more with those. Like, let's say you're Amazon, and you need to route all your shipping trucks all over the place, and maybe now you're shipping drones for that Amazon Express thing. You need good knowledge, good up-to-the-minute knowledge of weather and hazards in your way. So that's a use case. Google, in fact, I'm just remembering, they have they're working on a project called Loon, which is flying balloons very high up, kind of like weather balloons up in the stratosphere, that would provide internet connectivity to parts of the world that don't have it. And the balloons move by actually raising or lowering themselves into wind streams that are going in the right direction. So they try to maintain their position just based on the wind. So the NextRad data won't help in that, but the model outputs, which do model, among other things, wind speeds and directions at various levels in the atmosphere, would be very useful for them there. So that's another use case I've heard about. I guess those are some of the ones I've heard about. Our premise is there are other use cases we haven't thought of yet, but that somebody clever will, and get some of that untapped value out of the data doing. I mean, if we knew, oh yeah, here's this great use case, we might have done it a while ago. So we'd like to engage the expertise and the creativity of the outside community to come up with use cases and help these collaborators decide which data to bring into their clouds.
Okay. Next question. You said there is a fee to analyze the data in place. What is that fee or rate? Right.
So if you compute on Amazon, you do have to pay a sort of per hour CPU charge. The fee is highly variable, and it's not paid to NOAA, by the way. It goes to Amazon. If you want to get their most powerful machine and you want it right now, it's going to cost $5 an hour. If you want a lower powered machine, it's less. And if you're willing to wait, then it's very, very cheap, pennies per hour. There's this thing called the spot market where you say, hey, I want to run a big job. I'm going to need, 100 computers to compute for an hour. When the price drops to less than this much per hour, give me some machines and let me run on them. So the situation is they have a lot of machines with idle capacity, and so they can sort of shift jobs over to them for people who aren't in a hurry to have that job done. And you can get these idle machines very cheaply. So from pennies to $5 an hour, depending on your requirements. And I should say, there's also, at least on Amazon, not quite as familiar yet with the other ones, there's a free tier. So if you're a new user, you just want to experiment, you get some number of hours for free and some amount of disk space for your results for free. So you can actually try things without any financial investment on your part. But if you did want to kind of operationalize things, there would be some ongoing cost, which you're free to recoup by selling your new app, your value-added product to anybody who wants it.
Okay, next question. This is, so for GOES-R, which uses GRB, and GOES 13/GOES 15, which uses GVAR or GVAR, you're saying that you will standardize the output source to HDF5. Also, will you be focused on just providing imagery or other data, such as lightning?
At least the imagery, not sure about the lightning, I'll have to ask about that. But yes, my understanding is the plan is to send the data out to the cloud providers as HDF5. HDF5 was already planned for the new GOES-R, so this would involve just transforming the older stuff to that format so that the two would be as compatible as possible.
Okay. Next question is, what tools do you use to keep the copy in the cloud current?
So if we're actually still working on those. If we know something needs to be updated, we can notify the providers and just sort of push it out to them. What we don't have yet is a more automated system where they're involving checksums or hashes where people could verify that that everything was current and correct and that a specific data file, say, matched what we have in our archive. So those tools are still somewhat manual and rudimentary right now. That's one of the things that we're working on our end in collaboration with them to improve the time.
Okay, this one. Okay, excuse me. Has XSEDE, and that's XSEDE, been considered as a collaborator for non-commercial use? Jeff, I'm not sure if you're familiar with XSEDE.
No, I'm not familiar with it, although the name with that spelling sounds familiar, so I feel like I've heard of it before.
It's like exascale computing. Let me see. A virtual system that scientists can use to interactively share computing resources, data, and expertise at a really exascale level, I believe.
Okay. So at the moment, they are obviously not one of the 5 on this list. There'd be 2 ways to collaborate with them. One is they partner with one of these cloud providers, so there's no new agreement with NOAA, they're just working with one of these 5 as an intermediary. Or in theory, we could write new R&D agreements, basically similar to the ones we already have, with a new partner. That's not out of the question. If somebody is seriously interested in doing that, then contact us. Maybe contact me, and I'll put you in contact with the overall program manager, and we could talk about it.
Okay. And just to follow up on that, XSEDE was previously TerraGrid, an NSF-funded grid computing program, and they've scaled it up. So On
okay.
Okay, so that might give you a little more info. Next question, is there a plan to support NCDS format?
Well, yes, in the sense at least that NCDF is basically based on HDF5. NCDF4 is basically based on HDF5 as the underlying model. So that's one way. Secondly, some of our data are already in NetCDF3 or NetCDF4, usually utilizing the CF conventions, the climate and forecast conventions. So including model output sometimes. So depending on what data are requested, I could see a lot of it being NetCDF or HDF. And my personal preference would be that we rely as much as possible on that rather than just sending a bunch of ad hoc formats to the cloud that are, specific to that particular data set, but not otherwise in wide use.
Okay, another question here. Are there plans to extend CRADAs, that's C-R-A-D-A-S, or evolve them into a more permanent relationship between NOAA and the commercial partner? Also, are there plans to extend this project to additional partners?
So we could, as I mentioned, issue or sign CRADAs with additional collaborators. That would have to be discussed with the program management team, but it can happen in theory. So, as I said, if you're interested, contact me and we'll kind of get the ball rolling on that. In terms of extending them, so we have a 3-year term plus 2 one-year options. So we could just work under these for 5 years. And we and the collaborators have not yet decided what's going to happen beyond that. But certainly, let's say some data set does cause the creation of a new industry or service or product that people are relying on. We don't want to pull the plug on that. We're willing to keep this going on our end as long as desired, and we could make this more formal. We could say, okay, for this data set, this is the service level agreement. We're sending you stuff in this way as fast as we can, and we take it out of the realm of R&D and into production mode. So that could happen, but we don't have a specific plan to do that or specific decisions to do that yet.
Okay. All right, next we have a lot of questions here. Are the partners connected to the collaborations largely commercial industry partners?
I'm sorry, are they? Was that the question?
Yeah, are the partners primarily industry partners?
Yes. Yeah, these first 4, Amazon, Google, IBM, Microsoft, are all industry. Oh, you mean the other partners, like beyond them? Let me think. I guess I'd have to say primarily, yes. Sure, you've got companies involved like the Climate Corporation, the Weather Company, Esri, but then not all of them are commercial. For example, Unidata out in Boulder, that's part of the UCAR, you've probably heard of it, was very involved in helping get the IDD LDM feed of Nextrad working, and helping people understand the data formats and so forth. So there is room for non-commercial collaboration, and we would encourage that. I mean, if you're a scientist doing work on Nextrad or one of the future data sets, come here and compute. It's going to be easier and probably cheaper than buying a big machine with lots of disk and reading that off our archive and then working on it locally. Why bother? Just go compute on location and get your science out of it. I'd love to see new science results out of this. And also, I think the bird migration study I mentioned is not at all commercial. It's an academic type entity doing that.
Okay. We have just a comment from someone saying this has been a terrific overview of what NCEI is doing with the cloud. So thank you for that, Jeff. And we have a final, I think it's our final question here. What lessons have you learned that you would share with another agency looking to do something similar?
So a couple of lessons. One, we found that it was harder than we thought initially to get big data, large data sets, you know, read and staged and sent and verified. There was a lot of back and forth. Lesson two is definitely more in-house expertise. We had to call on the time of NOAA employees and contractors more than we expected. We thought, oh, well, we'll just send data, and they're going to have these expert partners on the other side who will say, you know, please get that data set. I want to compute on it. I know how to use it. But in reality, we have to work with them a lot, both on the technical solutions and on the understanding of the data, so they can, you know, use them properly and extract as much value as they can from it. Third lesson learned was an interesting one. You know, when we have a telecon with any one of these individually, you know, there's a lot of chat back and forth, but when they're on it together, they're very quiet. Nobody wants to reveal their, you know, secret business plan to the other one. So, you know, we give them info and they thank us, and we don't. In the group calls, there wasn't a lot of information sharing between these 5 collaborators. That probably would be less true with OCC, but you know, putting the commercial ones together, it seems like they'd rather think of their own ideas themselves and make them happen. So those are 3 of the main lessons. And I guess the 4th lesson is we should do this. So far, all indications are pointing to this has been a very, very good thing. You know, we've heard a lot of positive feedback about being able to get to the next red data more easily. So.
Okay, thanks. I think that's the end of our questions, unless someone wants, no, that's it. Jeff, thank you very much for presenting this talk today. We really appreciate your time. We appreciate the time of everyone who attended. For those of you in the audience, a couple of announcements. We want to make you aware that registration for Data Matters, the NCDS week-long series of 1- and 2-day courses for data professionals, is now open. Early bird prices are in effect right now, so it's a good time to visit datamatters.org to see what you're interested in and sign up for some classes. Also, please remember that DataBytes is a monthly lunchtime webinar series. Our next session will be Wednesday, May 4th, beginning at noon Eastern Time, and will feature Stephen Edwards of the U.S. Environmental Protection Agency. He will be presenting a talk called Accelerating Adverse Outcome Pathway Development via Computationally Predicted AOP Networks. We hope you'll join us then. Thanks again, and have a wonderful day.
Great. Thank you for the opportunity. It's been fun, and if anybody has further questions, feel free to contact me at the address shown on the screen.
Thank you, Jeff. Thanks.